Hello and welcome to our demonstration of the AdapterHub Playground application. First, you log in using a JSON file. This can be either your Kaggle API token downloadable from the Kaggle website or credentials provided by your server administrator if the computation will be executed locally. In the latter case, you need to provide the URL to that server. After login, all projects by the user are listed and new projects can be created. Provide a name to your new project and the link to the Google Sheet containing your data. Input data is provided via Google Sheets. The first two columns are reserved for textual input. The second column is only used for pairwise classification tasks. In the third column, one can provide existing labels, and the fourth column can be used for temporal metadata, which is helpful for later visualization. To link the data to your project, use the sharing functionality of Google Sheets. Within the project, a user can create so-called actions. Prediction and training actions make use of pre-trained adapters from the AdapterHub library and allow using those for prediction or further training on labeled data. Additionally, we offer text clustering on the data for further analysis. Let's use an existing adapter trained for sentiment analysis to generate predictions on our data. We provide a name, choose the action type prediction, define the column in the Google Sheet where the results are written to, and the downstream task, which is sentiment analysis in our case. We can also create training action type the same procedure. Additionally, we can provide training hyperparameters. Once the actions are finished, we can evaluate and investigate them. Here, we achieve an accuracy and F1 of 1 using the prediction task. We can also download a log file, the metadata, and the generated code. For our training task, we can now download trained weights for our adapter. If you look in our data sheet, we see that the predictions have been written in the defined column. Within a project, we can also visualize our results. We are given different chart options and can apply a minimum model confidence score. Then we define our group by variable for the x-axis. In this example, we could use the result of a clustering action. Then we select the data we want to show in the chart. Here, the distribution of gold labels within each cluster. We can also visualize combined dimensions. For example, if we are given temporal metadata, we can show how the distribution of positive texts in cluster 1 changes over time. Okay, thank you very much for listening and have fun exploring the AdapterHub Playground.